And we should be live. Welcome to another live stream repair. We've got just this one HomePod here from Joshua sent in today for no power repairs. And then I've got some other things sitting around that if we've got the time that we're just going to tinker around with here. So let's go ahead and jump right into this. Got my power cable all tangled up here. Alright, so here's our power cable. As always, we're going to go ahead and check our symptoms here. So yes, indeed, we've got no response there and about 4 watts of power draw from the wall. So this is all pretty much what we expect to see when this Schottky barrier diode on the amplifier fails. Let's go ahead and take this apart and find out for sure what's going on from the inside. Okay. Let's go ahead and start by cutting the adhesive off that's holding this top on. There we go. Let's get the display off now. Alright. Okay. Let's get that frame out now. And then that logic board can come right out. Let's work on that ribbon cable. easy does it. It's time for the pry. Okay. Easy peasy. It's the subwoofer's turn now. Let's check its current condition here. Voice coil looks good. Feels nice and smooth. And it smells great. It smells like a happy little subwoofer. Alright, so let's get this layer out. Good morning, Mr. Chicken. Let's get that power supply out. Disconnect the ribbon cable down there. And let's get this amp out. Okay. There we go. Put that all to the side. That's got some schmoo on there. But everything else looks in good condition. We've got a date code on our diode of 1746K. So I think we all know what to expect when we test that. Yep, that's a dead diode. Let's get that thing pulled off and we'll replace it with a new one, see if this board turns on. There we go. Old diode be gone. Here's our new one. We'll get that prepped. Beautiful. Looks like we bumped this guy a little bit, so we'll put that back into its place once this all starts to melt. It might even just pull itself back into place too. There we go. That's looking pretty fantastic. Let's get that cooled off here for a few seconds and then we'll give it a test. Every time I push the mute button on my microphone, it mutes and then unmutes itself. That's hilarious. Okay. Let's put a power supply on there. Ribbon cable. For our logic board. Subwoofer. Power connector. Let's make sure our meter's turned on to DC voltage mode so we can measure any DC offset if it's got any. And we got power. Okay. What have we got? So our base is working, we've got power just fine, and we're sitting at around 5 millivolts of offset. So that is pretty spectacular in my books. This board looks ready to go. So let's put that away. Get that power supply and that logic cable off. Those are just our test parts. Here's our shell. Let's get the amp put in. power supply. Let's get that plugged in down there. Yeah, there we go. Get our rings in. There's a little extra here that we're going to take off. That'll interfere with the basket sitting nice and flush, so we'll want to make sure that's all clear. All right, that'll work. Okay. Drop the base. Base. cover. The last melon. Alright, what do you say, folks? You think we got it all? Let's find out. Give it a few smacks, and you've got yourself some power. What do we got? Oh, did they disable touching? Let's go ahead and do this. We're going to trigger a factory reset on this. We're not going to actually fully factory reset it. We're going to let go before it actually does it, but I just want to make sure it produces sound in response to touch fine. Looking good. It turned red. And it turned off. Interesting. We know that the amplifier works because we tested it with our power supply and logic board. Huh. We've got an interesting case on our hands. Let's get this back off. And the first thing I'm going to try is a different display. Same logic board, different display. Alright, what's that do?
Your HomePod is about to reset. I I'm having trouble connecting.
Okay, so it works fine with another display. What the heck? But with their display, do we have... Oh, I see the problem. If you look, there's actually enough of a gap underneath the corner here to actually stick my tool in there. I think what probably happened here, when I opened up their box, unfortunately the top half of the HomePod here was directly up against the side of the box, and I think what probably happened was it must have gotten bounced around pretty well in shipping. Of course, we had the root issue that they sent it into us for, which was that no power issue on the amplifier. We got that fixed up, but unfortunately along the way here it looks like it incurred some additional damage to this display. Because the whole top half of this pod was basically smashing directly up against the side of the box. They probably didn't handle it too well getting it to us. And that's okay. We've got enough of these displays that I don't need to charge an arm and a leg to replace this for them. And honestly, I'd much rather... I'm totally happy replacing a display as long as it's not their logic board that's actually faulty without a way to repair or restore the software on it. I'm much happier to replace the display. So let's get that back on there. Working display. We'll screw that back down. The cats are going wild. Okay, let's stick this back on there. Okay, take two. Plug it into power, smack it around a few times, and there you go. So their display was damaged. It's interesting that it makes it far enough to show the boot animation, and it even responds to touch for a second there. You can see it turn red if we hold it down after it powers up. But it's just damaged enough to cause it to not finish booting up. I've never seen that before. But sure enough, if we get real close up here for you folks, let's see if we can focus on that. Right here, there's enough of a gap for us to almost get under there, which tells me that the display was pushed in like this. You see that? Yeah, that's okay. How are we looking?
I'm having trouble connecting to the internet.
Aren't we all? Volume buttons light up nice and even. So we got this one all fixed up. Lol, what's the story? Get out of here. What's the story behind the sad face HomePod mini on the top left? So this guy, this was part of a lot of broken HomePod minis that I bought, and all 5 of them were described as won't power on. So when I got them, I tried plugging them into OEM Apple power bricks, and none of them, of course, showed any signs of life, just as described. So I plugged them into my USB-C MacBook, and to my surprise, 4 out of 5 of them showed immediately in recovery mode and allowed me to restore them from my MacBook. And I had 4 out of 5 working HomePod minis for around, I can't remember the exact price, but it was somewhere around $10 to $20 a piece. So I was pretty happy with, 4 out of 5. But Mr. Number 5 here, he unfortunately does not show up in recovery mode no matter what I try connecting them to the Mac. And they do not factory reset. All they do, and all they've ever done, and all I've ever been able to get it to do, is sit here and boot loop just like this. And he's been joining us along for the ride for our HomePod journey, our HomePod repair journey here. I was kind of hoping that one day he would get a little jealous of all these other HomePods working again, that maybe they would, knock themselves out of it. But unfortunately, they've been sitting here boot looping for a few months here on the stream with us, and they haven't gotten any better. I did take the speaker out of it because I was curious what it looked like. And it's quite a cool little design there. So you've got the mid and bass speaker, as you can see right there. And then you've also got the tweeter that's actually built in to the cone for the bass driver there. So pretty interesting design. But
There's a problem with the...
Well, there's always a problem with the Wi-Fi, isn't there? Let's go ahead and put Joshua's pod away. And let's see, what should we work on here? I kind of want to figure out this MacBook Air that's not powering on. Yeah, I think we'll mess with this for a little bit. So, just to recap with this MacBook Air, Jesus sent this one in. Let's go ahead and update the text on our screen there. Jesus sent this in with no power symptoms. It showed an orange light on the charger when plugged into power, but it wouldn't power on or give us any fan spin or anything like that. When I did a close inspection, I found there was a small capacitor over on this area of the board that was shorting out from what appeared to be a corrosion issue. So we cleaned that area up, replaced that shorted capacitor with a good one from our parts board here, and got rid of that short. We don't see any more shorts in this area. But it also ended up blowing off one of these chips over here. So we replaced that, and then we noticed I think this is the 6259 chip. We noticed that getting warm, so we swapped that chip from our parts board, and we are still in the same position as we were yesterday. We get an orange light on the charger, but no power, no fan spin. One thing that's important to note, I think, is something that actually caught me off guard yesterday, is this ribbon cable right here. What's interesting, and I don't know if this is expected behavior, But if I don't have this ribbon cable connected, it's like a complete crapshoot whether I see any power light on the charger when I plug it in. Sometimes it works and sometimes it doesn't. But if I have this ribbon cable plugged in, then it seems to work. At least it seems to show the orange light every time. The thing still doesn't turn on. But yesterday when we were given this a look over, we didn't have this connected every time. And we were scratching our heads wondering why our power or our charging light went away. And that's why. So let's go ahead and plug this back into power again and just double check and make sure that this still doesn't have any fan spin. So we've got a green light, it turns orange, but no fan spin. I actually just noticed one of the screws for the CPU heatsink is also missing. Huh. Okay, so we're gonna grab our thermal camera, see if we can spot anything that's heated up. Everything on this side of the board looks cool. I don't see anything getting warm except for just a tiny little bit of heat. Well, now I can't see it because this is just giving me nonsense. No, nothing really useful with our thermal camera. So here's what we're going to do. We're going to pull up YouTube. This is what, an A1244 or A1466? A1466, orange light, no power. And we're going to see if anybody else has figured this out already. See if we've got any common problems that we can save ourselves a little time on.
Hey everybody, so today what we actually do have here, this is a nice repair, still a nice MacBook. It's the A1466 MacBook Air. This is a 2017 model, so it's not the latest one, but it's the one right before the redesign. For this one in particular, we actually do have a problem with this laptop. So this laptop in particular has no power, but when you plug it in, you do see that there is an orange AC light. That can mean a lot of different things, especially for this type of MacBook repair, so let's just at least diagnose it and see how it's going to work. So the first thing you want to actually do is test it out, at least to see what the issue is. So we're going to go plug it in there, and we do see that we are going to actually get our orange AC light whenever we do plug it in. With this orange light on, the laptop is not powering up.
I'm watching a video from LapFix right now.
Warm here. So there must be a short.
Here you guys go. Now you can watch
somewhere,
along
and
with
we need
me.
to exactly figure out what that issue may be. For something like this, we definitely want to do a few different things. You want to at least check the board itself to see if there's any obvious corrosion, especially on the top of it. After that would be at least to remove the board and to see if there's any other type of corrosion that we might see, or any type of damage, or any burned components, or if there's just a short actually on the
Oh, I
laptop
wonder if
itself.
you guys
what
can
we're
even
gonna
hear
do
this.
is we're actually going to go test before we do remove it. We're going to go ahead and test. It's called the PB Bus G3 Hot Main Power Rail, and what that is, we're testing this for a short to see if it does short to ground. Now this one, it's very, very important because this rail is always on when the MacBook's on. It's also that one wire that allows the charger to talk to the SMC. And you always want to check this rail to see if there's any shorts in case you don't have any full voltage.
Whoa, 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 whoa. Whoa, 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 whoa. Hold on, bro. Slow down. Where'd you probe that?
Books on. It's also that one
Oh,
wire
okay.
that allows the charger to talk to the SMC. And you always want to check this rail to see if there's any shorts in case you don't have any full voltage going to the laptop. Usually this one again is shorted to ground. This one could be found at F7140. This you could actually test. This is actually right, that big coil that's actually right parallel to where the Wi-Fi card is in this one. And when we attach it here, we're going to be testing for a short. And what we should be getting is at least 8.5 volts. If we're getting 8.5 volts around there, that means the SoC will work and it'll communicate with the ISL. And what that will do is it will set the final voltage is ready for the MacBook to actually receive them. So we are testing it out there, and we do see that we are getting our 8.5 volts. So that's a good thing. That's what we're looking for. So we don't really see that there is an issue there. Now we definitely want to remove the board and at least take a look at it and see if there's anything else that we do see. Just to
So
see
he
if there's
wants
anything.
8.5
This rail is
volts.
always on when
I
the
can't
MacBook's
see
on.
where he's
it's
actually.
also that one wire that allows the charger to talk.
So he's what? Going ground. Okay, so we've got 8 volts on the power rail. That's good.
To the S. It's a good thing. That's what we're looking for. So we don't really see that there is an issue there. Now we definitely want to remove the board and at least take a look at it and see if there's anything else that we do see. Just to see if there's anything very obvious there. We like to do a quick scan to see if there's any issues with any components there, if there's any liquid spills or anything else. But it's always good to go under microscope to see, because sometimes you might not see if there's a liquid damage or there's a burnt component or something very obvious right away. So that's what the microscope does, and sometimes you can't see underneath the components there, or there's something very, very hard to see. So we're going to be doing that. And the most important thing we want to see is especially that there is no damage to the actual SMC. And this, we do see that the SMC looks very clean, and we are getting an orange light. The SMC has roles. For something like this, it can also control the thermal and power management. It does input, output, video mode switching, lots of different things, especially for battery charging as well. For if something was impacted like this, it's definitely a major blow, and a lot of this does go bad. If this is bad, then you have a pretty big issue. But it's usually the one you can see. It's usually taped around with the glue, especially on the A1466 models. It looks pretty clean. Nothing looks pretty damaged. There doesn't seem to be any liquid spills. It doesn't really seem to be anything really wrong. We can of course test the board a little bit further. Since we have everything unplugged, we're just going to go test it one more time to make sure that nothing else is really giving us an issue. Or there could be another short maybe going on with maybe with anything else, or maybe check anything before we actually do work on the board, because you always want to make your work, especially if you're a shop or anything like that, you want to start with the most basic type of issues first and rule them out, and then we'll work on the harder stuff, especially if it's a board level repair. And now, since we're testing it, we didn't see anything on the board. We did notice actually when we do plug it in that the fan does spin, processor does get warm. So it does look like that there is something actually shorting the board itself there. And it doesn't look like it's mainly a power issue with the actual board itself. So, and what we noticed is when we plugged in the trackpad cable that we were actually getting the short and we weren't getting it to turn on. So it does look like something is damaged there. Most of the time you would see if there was any issue with the cable, you would actually see the actual damage to the cable itself there. But in this case, we do know that there is a trackpad, that the trackpad actually does have a board on it, and it has lots of components, so maybe something went bad there. So let's go ahead and we'll take a look at that. You do have the trackpad here, and we're putting it under the microscope, and
No,
you can see
it's
exactly
nothing
where
but the
that cable.
trackpad, because this isn't turning on without the trackpad plugged in. What about this one?
Hey everyone, so today we have here
Hi.
another MacBook info stain here, and that's at least an indication that, at least in the back of my head, I'm thinking, well, it's probably some type of liquid spill or anything else like that. So I don't really want to plug it in, especially if there's any liquid spill, so let's go ahead and unplug it, and let's see if this has gotten impacted too, because the SSD is right there. Sure, SSD looks pretty good here, at least the connection looks. Processor is completely dead. It's not getting heat or anything. Now we need to go ahead and investigate. See if there's anything really getting warm on here.
Paul Daniels. What's up, dude?
Okay, I said everything, but you know, I'm being dramatic here, for goodness sake. Dark corrosion there, that's not good. This is a real splatter field. Oh great, real corrosion there. Bit of corrosion there.
Well, got a lot of corrosion there, oh boy. Let's go under the microscope and see if maybe we're missing something here. There's our SMC. Oh, hey Tony, welcome to the stream. I'm just not seeing anything. Oh, I saw something there briefly warm up. Oh. 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 So that's supposed to have 20 ohms. I got excited. We're just poking around, seeing if we can find any differences between this board that powers on and the board that doesn't. See if we can find anything maybe shorted out or maybe missing. This GL3219 chip looks kind of toasty. It doesn't look obviously damaged, but the lettering is kind of unevenly worn. But that's a USB controller, so I don't think that has anything to do with our lack of power. Alright, let's see if we can find any other information here from anyone. Hey, Mars. I just cannot find anything obviously wrong with this board. Yeah, let's try Louis Rossmann. I'm kind of surprised that none of his videos showed up in my first search there, so we'll go directly to his channel and look. Where's the search channel option? Oh, here we go. Wait a sec, isn't it kind of strange that it turns orange? Shouldn't it not be turning orange? Shouldn't it stay green? Okay, so it should turn orange. I just had to sanity check that. We gotta start getting smart with this.
So today we're going to be looking at an 820-00165 MacBook board that doesn't turn on. Let's see if we can figure out what's wrong with this MacBook and make it work again so that we can join the innovation economy. Now, we're going to put this on the desk. First thing we're going to do is see how much power it's drawing from our power supply when we turn the power supply on. If you want to check out Paul Daniels' software, check out pldaniels.com, a website that has a wealth of quality software on it. As you can see over here,
This is fact.
it's drawing 36 milliamps.
Yeah, we're not
Usually
gonna be able to
22
see how many
milliamps
milliamps this is
is
drawing.
indicative of PM Sleep S4L missing. 100 milliamps also says power good issue. 200 milliamps short to ground on PP bus. 36 milliamps, not quite sure. So what I do here is I've got my power supply on my desk. This here is my power supply that you can't see with a terrible camera angle because of my tiny store. And this is it plugging into the board itself. I'm using that as a power supply, and I like to use it as a power supply because it tells me interesting things that I wouldn't otherwise know unless I measured a bunch of stuff on the board. It kind of gives me an idea at a glance what could be wrong with the board. So let's go over and figure out what it is. So it's not power god, so we're going to take a look through our power rails page on the schematic and the board view, which somebody was polite enough to provide. By the way, thank you everybody. I think it's important every now and then to start our stream off with a thank you to the brave men and women that go out there every day and put schematics on the internet so that people like me can find them and then use them to repair these products. So just a moment of silence and appreciation for all the hard work of those individuals, all the work, effort, and risk that they took so that we could have schematics. Now, going back over here, let's see what our power rails page looks like. Now remember, the G3 hot rails are the ones that have to be present first. G3 hot are rails that are on all the time. S5 are going to be rails that are on when the computer's off. S4, rails that are on when it's hibernating. S3, rails that are on when it's sleeping. SO, rails that are on when the computer is actually working. And these are typically listed as a suffix of the actual name of the rail in the list. See that? So, let's check and see what we've got on our G3 hot rails over here. So I'm going to go over to the G3 hot rails, and the first one we have is a PP bus G3 hot. Now remember, in order to get a green light in the charger and for anything to work, PP3V42 has got to be the first rail that shows up. But we know that PP3V42's got to be there because we've got a light in the charger. So the PP bus is going to show up on this fuse. On one side of the fuse, we get 0 volts. On the other side of the fuse, we get 8.59 volts.
So do we.
Let's take a look at what that fuse is for. What's going on down there? Let's see if we can figure it out. Why it doesn't work. Alright. This is a fuse for the PP Bus G3 hot. So over here we have the ISL 6259, which is going to take our power from the charger up here. 18 volts from the adapter. It's going to switch on, off, on, off, on, off. You're going to get pulses of 18 going over here. And after the coil and with those capacitors to ground, it's going to get evened out to a smooth, nice 8.5 volts. Now we got 8.5 volts here, 0 over there, meaning that the fuse is probably blown. Let's just double check and see if that happens to be the case. We're going to unplug the charger. We're going to have the multimeter in ohms mode. We're going to measure that fuse, and the fuse appears to be dead. 6 million ohms.
Yeah, our fuse is good, so it's not a blown fuse. That's unfortunate. Let's see.
Everybody, so today I have
Did I
in
watch
for
this one
repair
yet?
another MacBook. This is the A1466, fun model, MacBook Air. And if not, we can try plugging in, we can try removing the board. Just go always work to do the easiest thing first. Bring out. Let's not worry about that. Let's actually just remove the board now. That does have what? This is the keyboard underneath there, and we're, because it's like, and we should probably go, oh yeah, we're not gonna get it, and we get a power on. I think we see that backlight. Hey everybody, so today we have here another A1460. take a look and see really what's other. Okay, I do feel actually ooh. Okay, I think I found our component.
Ah, man, nothing's warming up on this. So I'm wondering if maybe an IC somewhere was just shorted out for too long and bit the dust. But unfortunately, I'm not experienced enough to know what we should be probing and seeing voltages where. I need to pull up the board view, figure that out. What is the most common MacBook mother logic board failure?
S5 are going to be rails that
Is
are
this
on
the
when the
same one? Is
computer's
this the
off.
fuse?
S4, rails that are find
Yeah,
them.
no, that's the same one that we just watched. Let's go back to the old YouTube search here. Oh, and YouTube only gives you like 10 videos that you actually search for, and then a whole bunch of things that it wants to recommend you. Oh, hey. Oh, this guy, after doing the initial cleanup, a misguided attempt to refill the SMC results in us having to reball the SMC. I think I'm going to tap out on this one for now. Looks like we're about out of time. Alright, folks. I have a hard time giving up on projects, so I'll definitely be coming back to this one after I grab some schematics for this thing and some board view software and do some more looking around on the internet to see how exactly I should be troubleshooting this instead of just kind of winging it here and going in blind, you know? So if you guys have any questions or comments about any of our repairs here, or you think you've got an idea what's going on with our MacBook Air board, feel free to leave a comment down below. Check out the website, nixfix.com, where I've got a whole bunch of information on HomePod repairs, including common issues and steps on how to diagnose and repair those issues, or reaching out to me to send yours in for repair here on the channel. Hope you